Here we're going to solve an equation with variables in the denominator. What you want to do is get those variables out of the denominator. What we did in a previous lesson was, if you kind of focus on that fraction, if I want to get rid of the denominator, I multiply by that over 1 and it cancels. But I would have to do that to everything, and that's not going to cancel my x plus 3 and my x squared minus 9. So it's kind of not helpful. We want to find... It is helpful, but it just doesn't do the full job. And you want something where you could multiply the whole equation by it and it's going to do the job. So you want to find what's called the least common denominator, the LCD. The name of it does not matter. I'm just giving it a name, so maybe it'll jog your memory when you're doing these problems. You want to find a denominator, smallest denominator you can make, that includes all of the pieces of these denominators. So it needs to include an x minus 3. The LCD needs to include an x plus 3, because that's what those fractions include. Now this, if you factor it, this is a difference of squares. So this factors into x plus 3 and x minus 3. Those are the pieces that make x squared minus 9. So that means the LCD also needs to include an x plus 3 and an x minus 3. So if we go one fraction at a time and build our LCD, we should come out with the correct way to solve this. So you look at your first fraction, x minus 3 needs to be in the LCD. So I've got that one. Now I look at my second fraction, it needs an x plus 3. So I look at my LCD. Do I have an x plus 3? No. So that means I need to add on an x plus 3. So now I've got that one. Then I go to my third fraction. We're just going down the line. First I look for x plus 3. Do I have an x plus 3 in my LCD? I do, so I don't need to add another one. Then I look for x minus 3. Do I have that in the LCD? I do, so I don't need to add another one. So this is what we're going to multiply by to cancel these denominators. So let's just kind of rewrite it. I'm multiplying everything in the numerator by this LCD. So we've got the LCD times 2x over x minus 3 times the first fraction. Then we've got the LCD times the second fraction. And we have the LCD times the third fraction. And I'm going to write this in factored form. And if you're confused as to where these are going, these all have ones under them if you want to view them as fractions. So then we can cross cancel. So we've got x minus 3 cancels in this equation, which leaves a 2x to distribute, which would be 2x squared, and 6x is what it leaves behind when you multiply by the LCD. Here, x plus 3 cancels, which leaves behind an x minus 3. You're going to distribute the remaining 5. That gives you 5x minus 15. Over here, the bottom cancels with the LCD completely, so it only leaves that 36 behind. So now we've got an equation where the denominators have all been canceled out. If we collect like terms, put your x's together and your constants together, we get 2x squared, 11x, and negative 51, or negative, well, I'm in negative 15, but we're going to subtract 36 to the other side, and we get negative 51 equals 0, because we want to solve this. So we're setting an equal to 0, and you can either do quadratic formula, or you can factor it, or complete the square. I'm going to factor it, so I'm going to multiply 2 times 51, so that is 102. And we are looking for factors of 102. So let's, 1 and 102. 2 goes in 51 times. 3 goes in 34 times. 4 does not go in. 5 does not go in. 6 goes in 17 times, and those two, if you subtract them, make 11. If you put the negative on the 6, and it does need to make negative 102 since it was a negative 51. So those two factors work. And so we borrowed the 2 to get those. We're going to have to pay back the 2. So then reduce, you're going to get x minus 3. And 17 over 2 does not reduce, so move your denominator in front. And then set each factor equal to 0. And we're going to add 3 to the other side, and we get 3. We're going to subtract 17, and we're going to divide by 2. So we get negative 17 halves as the other factor. Then at the end, you want to go back and check your work, and you need to notice every time x is in the denominator, you got to check really carefully. Whatever factors you get cannot give you 0 in the denominator, and 3 will give you 0 in this denominator and in this denominator, which means that this is an extraneous solution. It does not work. So negative 17 halves is the only solution.